Hello everyone. Today's going to be a quick video, uh, not of a major project or anything, just a little thing I wanted to test because I got a couple of bits the other day. So, right, so this is what I got. I got a power jack. So the idea here is that I want to create something that can do a similar job to my power supply, but without actually having the breadboard power supply sitting here. So I just wanted to see how it works and all that stuff. Just a bit of experimenting. Um, so I just tried filming this once and then I couldn't work out what connections were what here because I kept using this one. This one on the side doesn't do anything. It's not connected. So these are the actual important ones here. These two small ones. That's positive and that's ground. So I'm going to plug this in. Right. So wait, it doesn't go in like that. Okay. Put this here. I might need to get a couple of jumpers just to get it out of there. So we have orange as positive because why not? And I think, yeah, black as negative as God, that not going well. There we go. Right. So I'm going to plug this in and I'm going to measure it with my multimeter. So we should be getting roughly 9 volts out of this. Let's have a quick gander. We want to be measuring direct current at 20 volts, roughly. So this orange one should be, hold that there, and yeah, as you can see, we're getting about 9.4 volts. So we'll just call that 9 volts. Right, so what I wanted to do is what my power supply does is bring that down to 5 volts. So I've got these things, they came yesterday, they're Zener diodes. So these things have a limit on how much voltage they can stop coming through them. So these ones should be 5 volts. So if you have 9 volts here, this can't take it and it will open up and let the rest of the voltage through. So 9 volts here, this can only stop up to 5 volts. So 4 volts comes out of here. So it's basically 9 minus 5. So this will be 4 volts and this should remain at 5 volts. So, I mean, these are made of glass, so I'm going to be going to use my tweezers to bend these because if you've ever, I've done stuff with glass before and it's smashed on me, so be really careful with these. So the other glass things I've done were reed switches. Those are admittedly very delicate, but these should be a bit more sturdy. So I'm going to assume, actually, you know what? I've got this out. Let's do this properly here. I'm going to assume this is the blocking side. So if we do this, it should beep. Well, it's not beeping, but it's doing its job. Let's see here. It should do nothing. Yeah, okay, so it's not beeping, but it's doing its job. So this is the blocking side. So we'll put that in here. Okay. Now this end should go to ground. And this end should go to there. Now I'm gonna put a, actually no, I need a resistor, don't I? Forgot about that. Where's my resistor? Right, let's grab a. I haven't got any proper resistors for this. Generally you need a power resistor, but because I'm only dealing with 9 volts, I should be able to get away with like 1k resistor. Let's try a 1k resistor. If it blows up, it blows up. We'll see what happens. Right, so we want to take that from positive there, and then we do this. Right, I'm going to add another one just to shoot off and measure that. Right, to be honest, I only just realised that was on the whole time. Well, it seems to be fine. Generally, a power resistor would be like a very low ohms, but have a massive heatsink on it and stuff. So let's measure ground. Let's measure over the diode here. So I think this would be 4 volts. No, that's still 9. Oh wait, maybe I'm doing it wrong here. Let's measure this first. It should be 5. No, that's 9 as well. What's going on here? Is it because there isn't a load on it? Okay, let's try adding a load. We'll just use another resistor. Grab it out of here. Right, okay. Let's try adding another load. And we need to put that to ground as well. Come on, there we go. So just bung that back in there. Nothing's blown up, so that's something. Right. Oh, look, there you go, 5 volts. Well, 4.7, but yeah, so this will measure 9 volts because that's the difference between. Actually, no, it's measuring 5 as well now. Okay, so I guess you need a load to make this work. So if I take the load out, it should be 9 volts again because that's the difference over this. Yeah, okay, so that's working. Okay, so ground, load. Yeah, so that's keeping 5 volts along here now, thanks to this Zener diode. And everything's hunky-dory. The problem is with the resistor acts as a current limiting resistor. So you could only manage so much. Like if I added more transistors here, or resistors here, or diodes, or LEDs and stuff like that, they would quickly start losing power because not much current is actually coming through this. So a power resistor would be like 0 ohms up to like 8 ohms. So they let through a lot of current, enough to power stuff, but I can't use a normal metal film resistor to do that because it's very small and doesn't dissipate heat as much as a power diode, which come in like big aluminium heat sinks. So I think for a real project, I'll have to get one of them. And obviously I won't be able to fit that on a breadboard, but yeah, I'm really happy with that. I'm glad that works because I didn't rehearse this or anything. So I'm happy that works. What else was I about to say? I don't know. Thank you for watching, and goodbye.